Hello, my name is Amin Sheikh and this is my lab 2. So a brief overview of this lab. So the purpose is based off of lab 1, which was an experiment with two pieces of charged tape and ultimately to find out the excess charge. So some key fundamentals is that we modeled the system before as 2-point charges, but now what we're going to do is model the system as a uniform distributed charge or a line charge. And so we'd use Newton's second law and Coulomb's law to determine the electric force between the two charged shapes. And from lab 1, we calculated the surface area to determine deficient electrons per atom. So a brief introduction to the results is that the distance between the two tapes was 2 centimeters. And I calculated the force of gravity acting on the tape to be about 0.002 newtons, which the electric force was just the opposite of that. And we determined that the tapes were positively charged, and the tapes as a point charge had 9.3 times 10 to the negative 9 coulomb, and as a distributed line charge had a charge of 2.1 times 10 to the negative 8 coulombs. So some assumptions is that gravity is the only non-negligible force, which makes it fair to assume that F electric is equal in magnitude to the force of gravity. So tape acts as a uniform point charge is an assumption made in lab 1. Now we assume that the tape acts as a uniform distributed line charge, and that both pieces of tape have roughly the same positive charge due to ripping. So this is the experiment set up from lab 1. It's just based on lab 1. And the results are that the charged tape is attracted to hands and is also attracted to negatively charged plastic pen, which again in lab 1 we discovered that the tapes are positively charged and that the separation between the tapes when put close together is 2 centimeters. So the force of gravity determined on the horizontally hanging tape was about 0.002 newtons, and so the F electric is just that, but the opposite. And by doing the calculations, we determined that the charge of tape as a point charge was 9.3 times 10 to the negative 9th coulombs. So as you can see here. But as a line charge, by using the equation of the electric force of a rod, the charge ended up being 2.1 times 10 to the negative 8 coulombs. And here in my GlowScript model, here's the code. I determined that the charge of the tape was 2.1 times 10 to the negative 8 coulombs, and that the magnitude of the electric force was 1.7 times 10 to the negative 3 newtons, which is roughly the same as the magnitude of the gravitational force. And you can see this is the bottom tape, this is the top tape, and all these vectors are the change in the length at each point, which all add up to this big vector. So some potential sources of error may be that the charge may not have the exact same charge. Also, the charge may not be distributed uniformly. Furthermore, in the experiment, there might be other forces acting upon the tape, such as air resistance, as well as the fact that the mass of the tape may be slightly more or less than calculated. So what if I had modeled each of the tapes as a single point charge like in the previous lab? Well, as I mentioned before, the estimated charge on the tape would be different. The value as a point charge would be 9.3 times 10 to the negative 9th coulombs versus 2.1 times 10 to the negative 8th coulombs as a line charge. So why do these estimates differ? Which value is more likely to be closer to the real value, and why? So the calculations for the electric field of a line and point charge are different, since the line charge applies the principles of superposition. And since the pieces of tape more resemble a line charge due to its length, they are more long than they're fairly long pieces of tape. the values calculated as a line charge is more likely accurate um, in the scenario that we had in the experiment. Thank you.